Hello everyone, this is the time to start talking about SQL. Now we are going to talk specifically about retrieving data from a single table because it is the easiest scenario, and even though later the queries will become more sophisticated, I want you to understand that the start for every homework, for every lecture, and for every example is to understand the data. So this is a query that I already copied, ignore that. Our main example throughout the class will be the AP database, and you need to be familiar with it. By need to be familiar, first of all, you need to look at the data itself, at the descriptions, and the data types. And I guess the best way to look at data types is to either expand the columns in the database object explorer, or actually right click and click on design. So both will give you a very good idea about the data types, whether nulls are allowed, and so on. Why is that so important? When working with data such as filtering, grouping, and changing it according to some condition, for example, the data types play a crucial role. So if I was to compare two strings, it would be one behavior. If I was to compare dates, it would be a different behavior. So even though dates can look to you like January 20th, whatever year, if the data type is a date, this is the ordering according to the date. And if it is the data type is a string, then they are going to be compared as strings by their ASCII characters. So keep track of data types and ultimately keep track of primary keys and foreign keys. And the best way to do that is to create a new database diagram or use the old one, unless you changed the database. The old one should be just as good. So I'm creating a new one because I did not have any saved at the moment. So two orphans tables unrelated to anything, and as we go on, we will understand better and better the relationship between the tables. In this case, it is, in every case, one-to-many relationships. In terms, term ID is the primary key, and default term ID is the corresponding foreign key in the vendor. So the related columns can have slightly different names, and you need some understanding of the database and understanding of actual definition of this relationship to make sure that you understand how your joins work and things like that. For now, we don't care for the relationship. We will retrieve data from one table at a time. It can be this table, that table. At least you need to be familiar with the data here and understand that dates are in the small date type. There are some data types for dates, but in any case, this is not strings, and there are numeric, and there are actually variable character data types that is strings. All right. So let us try our first query. And notice by and large, this is our first. I may have closed my first query. There it is. So if I will switch the database to master and run this query, it will return an error. Invalid object name invoices. And that error will happen often because SQL Server does not always know from which database you are querying. And by default, the database is master. This is a system database. You don't need to do anything in it. But if you want your query to work, you need to either switch here to the appropriate database, AP, or alternatively add a statement here. It's not an SQL statement, it's a server statement. So use AP and go. AP, go. So this little statement will switch to AP database. All right, now select all from invoices. Here it is. Here is the entire invoice table. Because star is the wildcard, it means anything, any. And select any from invoices basically retrieves the whole table. Now, another thing, before we move on to any other select statement, SQL does not have loops. SQL is designed to list some columns that contain data that needs to be retrieved. So, and also various grouping or ordering or filtering conditions. In any case, SQL, very roughly speaking, will go through every row of your database and choose and retrieve the data that fits your query from every row. And that is the corresponding columns and corresponding rows. So second statement, we can run it, and it's also about invoices table from invoices, that is the reference to the table. And we select 3 columns from our original table, and then we order them by invoice total. And as you can see here, this is actually ascending ordering in increasing order, like increasing values. So keep that in mind. Now we can also calculate the value. And here it is. So invoice ID, invoice total, credit total plus payment total as total credits from invoices where invoice ID is equal to 17. So I want to copy this and actually run a query. So now I don't need use AP because we are connected to AP table. Let's run this. So what happened? Credit total plus payment total is a calculated column based on 2 columns from the invoices table. And you can look back at the invoices table, see again how it looks like if you don't remember. Here it is. So we have payment total and credit total, and we are adding these 2 as total credits. And now we are filtering with a where condition, where invoice ID is equal to 17. So remember these 2 values, invoice ID 17, 10, 10. We can, for a small table, it's not hard to go back and see the actual values and make sure that payment total plus credit total is indeed 10. And it is. So where condition filtered our table. If I was to comment out this condition, and it's a good practice to finish with a semicolon, finish every SQL statement with a semicolon. In this case, we have the values calculated for every invoice ID that was in the original query table. Sorry, in the original invoices table. Overall, it's a good idea to play with SQL statements, add or remove things, and that way you will understand how it works better. So this is an expression, and this is a new column name. So some expression is now saved, some expression is calculated, and the values are saved with a new column name, total credits. Here it is. All right, let's look at this statement. This statement is interesting because it uses the between, and this is what I was talking about, the importance of the format. Invoice date is in the date format, and that is the way the dates are compared, like you would expect them, like you would expect the dates to be compared. If it was just a text, just a string variables, they would be compared as string variables, and that can lead to unwanted behaviors if somebody is careless about the way the dates are stored, for example, or convert carelessly. So we choose 3 columns from invoices: number, date, and invoice total from invoices, where invoice date is between these 2 dates. And I would like to save it, copy and run it. As well, because as usual I'm going to play it, and so play with it, and so should you. Alright, so in this case we got some data retrieved, so between January 1st and May 31st, everything. Actually, it does look like the data stops. We also ordered by invoice date, so actually the data stops at in the beginning of April. So how about we narrow it down? 02, 01. So everything in January and first day of February. Of course, it got much smaller, as one would expect. And another interesting thing, you don't have to select invoice date as one of the columns here in order to filter on it, because you filter the original database. So even if I remove it here, this is still a valid query. You won't be able to see the invoice date, but sometimes you don't want to. You just want to see, for example, the totals over this period. This has less information, but my point is you don't need to include invoice date into the columns, selected columns, in order to filter on it. All right, we can also have a where clause with a total bigger than 50,000, for example, and that can return an empty result, so empty table, which is completely fine. So there are no rows in the database that would satisfy this condition: invoice total greater than 50,000. All right, let's somewhat expand the syntax for the select clause. With select, we can use all or star, or we can use distinct to remove the duplicates. Top and percent with ties. The fact that they are in brackets in this context mean that those are optional. You have seen select statements without any of this, but you can also use, for example, top 5%. We can code column specifications in various ways. So all column in base table, column names, arithmetic expressions, this is calculated expressions as a new column in the data that we retrieved. String expression, and we can use functions. So the rest of the chapter will provide the examples of each. This is a part of a SQL statement. This is not a whole SQL statement, so we can, as I was saying and showing in previous examples, either retrieve all or retrieve specific columns. And also, next example, we also create a calculated column. So invoice total minus payment total minus credit total as balance due. Naming conventions are important. As in every other programming language, they should describe what the column is about. What does it mean? Reflect, use, in other words. So what they are telling us is that the difference between invoice total, payment minus payments total, and minus credit total is the balance that is still due. If you're curious about the credit column total, you can go back to studying the table, think what kind of business could produce this kind of data or would care to retain this kind of data. And the idea, I guess, is that business can give credit to customers, for example, for a previous purchase or for a birthday or whatnot. Another example, this is also not a complete statement, just a part of it to show what can be done. You can use a string expression, in this case concatenation, vendor concat f name, first name, plus blank space, plus vendor contact last name as full name. So we are creating a column full name based on two other columns, first and last name, and we stick the blank space in between because we need to. And also we can use functions to calculate values, and getDate occasionally is useful. It is getting today's date, as in the date when you are running this SQL statement. Okay. Now, the second syntax is a valid syntax. You can still use it. I'm not going to talk much about the legacy syntax. Here is the more modern syntax. Select invoice number as invoice number, invoice date as date, invoice total as total. Now we gave aliases to each of the columns. Invoice number became invoice number with a blank space in the middle, as in two words. And in order to do that, we're not allowed to do that without brackets. So you need brackets. And other two columns got their aliases. And you can see that same columns have been given new names for readability, I guess, or just because we wanted to. And here is a no name column. Maybe I want to copy it and run it. Give me a moment here. My laptop is not the fastest, and SQL Server eats resources like crazy. All right, here we are. No column name. So I created a calculated column. The previous three columns were copied from the AP invoices table. Here it is from invoices. This is a calculated column, and I did not give it a name, and I can do that now as, say, bracket balance due. Here we are. By the way, if there is an error, it is often underlined. Sometimes it is underlined when there is no error and it's still processing the query. So interestingly enough, Management Studio kind of knows whether your query is correct or not before you run it, but it still takes time to run it when it runs it. It makes quite a bit more sense when you are actually dealing with big data. For small data, it's just too small. It's pretty much so small I can process it by hand if I'm patient. But for large data, pre-processing the queries and optimizing the queries is a very big aspect of retaining efficiency, retaining productivity. Back in the day, queries that would differ by a few keywords or like very small choices would give drastically different performances. At this point, to some degree, with the advancement of optimization techniques, optimization backend, it does not matter as much, but still it's better to write your queries well. Okay, so you can concatenate string data and vendor city plus vendor state, both of them were string, and concatenate them by adding just like you would in Python. If you like to make it more readable, you can add strings, constant strings in between with like commas and blank spaces, and this makes it a lot nicer. So it's important to go through a number of examples and get comfortable with a number of examples, because ultimately the amount of experience you get is dependent on that, and that determines your comfort with these queries. There are much more sophisticated queries later down the road. You can find YouTube videos about solutions to some interview problems from Amazon who have really more advanced queries. Alright, so arithmetic operations are the usual ones. Modulo is also known to you as remainder. Division, multiplication, addition, subtraction. And here is the very same example with balance due. So we have invoice total, payment total, credit total, and balance due. So the ingredients of the balance due calculated column by balance due are also included. Alright, so of course parentheses matter. Just like in math, parentheses matter. They determine the order of operations, and if an expression is in parentheses, it is calculated first. So in the first column, invoice ID plus 7 times 3. 7 times 3 is calculated first, 21. Invoice ID plus 21. So everywhere we added 21. In the second column, invoice ID plus 7, all of that in parentheses computed first. So we get different values. Remember that, just like in a math class. Okay. Two operators division, that is quotient. We have 9 divided by 10, that is 0. It's an integer division by default, because I guess invoice ID is an integer. And the remainder in that case is 9. So it's useful when you see a query and see the output, inputs, output, it's useful to check in your head that it's actually correct and what you expect it to be. So invoice ID is 10 divided by 10, that will produce 1 for quotient and 0 for remainder. Okay, I guess that makes sense. So order of precedence, your usual algebra order of precedence, parentheses, and then divide, multiply modulo, and the lowest priority is for addition and subtraction. Okay, now let us talk about the functions. I want to maybe run this query and show it to you. In the Studio. So we are taking initials from names. We take a left substring of length 1 of the string vendor contact first name, and left substring of the string vendor contact last name of length 1. So essentially we're taking initials and concatenating them together with this plus. So we have initials for each person. Okay, convert. So we can convert from one data type to another, and the order of conversion to what type? Car 8, 8 characters long string, that is precisely 8, not up to 8, but precisely 8. And we are converting payment date to it, and this is a modifier that we will talk about later. You want to understand the main logic here. So and in the end we are creating a statement. So invoice pound sign as a constant string. You can see invoice pound sign in every one of them. Then invoice number, comma dated, another string literal, and then converted value. Payment date was in date format. It was 8 characters long, and it was converted to 8-character string. And that's how we create this kind of long entry. A warning about the long entries. The problem is not that we are going to run out of space or in a column, but the problem is that in essence you are losing information. This can be good if you are like printing an invoice and you want everything maybe on one line and in one place, but for working with data, for storing data, this is very bad. In fact, the opposite procedure is often undertaken. If you have like long record of, say, invoice with all the invoice information, you have to parse it into multiple table and split the amount and the date and the invoice number, and that requires some extra skills with something called regex that allows you to to see the patterns in the string and extract those patterns from the string. Not going to worry about it here. Okay, this is a couple of functions having to do with dates, and of course that they have to be applied to dates or in the context of dates, not just strings. GetDate gets today's date. Today's date was when they actually ran the code. And date difference, first of all, units, days, invoice date, and get date. So a difference between invoice date and today's date. Very useful function, date difference. Remember it. Well, as in every programming language, there is a function, parameter, and argument. There is a difference between the two, as in every programming languages. Parameter is an abstract variable when we define a function. That's like f of x. X would be a parameter. And argument is, it can be a variable, which is equal to some value, which we supply when we call a function. So in this case, our function was date difference, date diff. The abstract function signature expects 3 parameters, 1, 2, 3 parameters, and as those parameters, I supplied day, invoice date, which is a column, and get date, which is retrieving today's date. Yeah, select statement returns all the rows. They can be ordered. You can see that the order is alphabetical by default, ascending order, that is alphabetical order for strings. And we can return all the rows, data from all the rows, but not all the columns. If we didn't filter it, that's what, or grouped it, that's what's going to happen. And we need to select to remove the duplicates. So let's do with and without duplicates. Removing duplicates may be important for various reasons. Select distinct vendor CT vendor state. I'm going to put this on a new line and kind of uncomment distinct. This way, we are going to have the length of the table the same as vendor's table. Whoops. I highlighted vendors, so it was going to execute vendors, and it cannot do that. Here we are. So the length of the table is 122. If you actually open the vendors table using top 1000 rows, you're going to see that the length is 122, and we only selected some columns. And when we choose distinct, we are going to drop all the duplicates. See, Fresno, California appears twice in this data because there were different vendors from the city, this state. Let's see. Are there any interesting duplicates? Aha, Fairfield and Fairfield. Notice that. So there is a Fairfield in Iowa, I guess, and Fairfield in New Jersey. So distinct, select all distinct tuples. In this case, we have two rows, two columns selected. In every column, we get a value unless we already got this value before. If Cleves, Ohio was already selected, then we don't select any duplicates. But in case only one of the cells in the row match, or less than all of them match, these two are different, we still get them. So this is how distinct works. And now select with a top clause and percent keyword. So select top 5% vendor ID invoice total from invoices order by invoice total descending. Now we want to select top 5% of our data. That implies that we have an order in it, and we are ordering according to some numeric value. Otherwise, what are you calculating percentage of? So my top 5% are of invoice total, and I know that because I'm ordering by it. So top 5 or top 10 or top 5% or whatever requires ordering to know, like, how do you choose the top. Alright, and you have seen that already. So let us go back to our auto-generated queries. Notice that by default this generated queries put column names into brackets so that they are always allowed, whatever that column name is. And this is select top 1000. So if my table actually was bigger than 1000, it would only take top 1000, and that's kind of enough to see what is in the data in some level. Not really, I would be happier, for example, if they retrieved a random 1,000 rather than top 1,000, but that is the data analytics / data science side of the story. So you want a representative selection rather than selection of top something. But for some applications, it's really useful. Let me do top 5% just to change something. So top 5% is by, and I did not order, so it's kind of confusing. What am I ordering it by? So order by invoice total. Invoice total. Alright, so now this is the smallest invoice totals. Ridiculously smallest. And let us try, and I'm fishing here to do the next thing, which is with ties. I think that way we might see a few more rows here with ties. All right. Yep, so there were actually some rows with $10 payments. Payment totals. Cool. And now you might want to say, I want to see the biggest payment totals rather than smallest ones. Order by invoice total descending. So, sorry for my inverted caps, but this is the biggest invoice totals. And this is not top 5, this is top 5%. That's why it is not 5 rows, but more than 5 rows. All right. And finally, we reached the where clause, and that is for the second part of the video.